Good evening, my dear students. I think you will be very much bored sitting at home, ideal. So, what we have planned to conduct classes through online. From now onwards, weekly once, I will send a video lecturing one or two topics, which will be followed by a worksheet. You have to listen to the video carefully and try to answer the questions in the worksheet. So, as a startup, let us go look into the next chapter, carbon and its compounds. Already you know about some basic details about the elements. So, some basic details, for example, atomic number. You know, any element will have its symbol. For example, the first element is hydrogen. So, hydrogen, the atomic number Z is equal to 1. So, what does it mean? It means the number of electrons in it is 1 and the number of protons in it is equal to 1. So, Z is the atomic number for hydrogen, which is 1. The number of electrons present in hydrogen is 1, and the number of protons, which is equal to the number of electrons, which is equal to 1. So, and coming to the atomic mass. So, if you look into the atomic mass, so if you put the symbol for hydrogen as H, the atomic number Z is written here and the atomic mass A is written over there. So for hydrogen, H1 is the atomic number and 1 is the atomic mass. It has, of course, you know, it has its own isotope, hydrogen 1 2 and hydrogen 1 3. So this we call it as proton. This is deuterium and this is tritium. So for proton, the mass number is 1. For deuterium, the mass number is 2. And for tritium, the mass number is 3. So of course you know now what is an atomic number and what is the atomic mass. For each and every element we have this. Next, coming to the electron sharing or the valence electrons that is present. So valence electrons. So what do you mean by valence electrons? Let us now write the atom structure. So if you write an atom if you draw an atom structure, in the center, you know, the nucleus will be present, and outside that the electrons will be revolving in an orbit, which we call it as electronic orbit, and of course different orbits will be present. The first orbit we call it as L, the second as M, first orbit K, the second L, third M, next N, O, and etc. So how many maximum number of electrons this will hold? So each orbit will hold 2n squared number of electrons. 2n square number of electrons, where n is equal to 1, 2, 3, etc. So just as a revisit, I am telling all these things. So for if you take k, n is equal to 1, so 2n squared is equal to 2 into 1 squared, which is equal to 2. So maximum number of 2 electrons the k shell can hold. Similarly, you take L, the next one, n is equal to 2, so 2n squared, which is equal to 2 into 2 squared, which is equal to 8. So L shell can hold maximum number of 8 electrons. Is it clear? So like this, the center nucleus will be present, and after that the electrons will be revolving around in an orbit, and the orbit are called electronic orbits. These electronic orbits are named as K, L, M, N, O.